We're graphing these things, and I gave you guys 4 of them to try for homework. How did those go? Good. All right, so we're going to do a couple more together today and make sure that we're on the right track. So when we go through these, on a test or quiz, I'm not just going to say graph it and leave you on your own. I am going to break it down to like A, B, C, D. So I'm going to say part A, factor the numerator and denominator. So you don't have to remember what the steps are, you just have to be able to find them and put it on a graph. So if I were factoring, what would I do to factor the top? Flip the slide. Okay, that would break into x minus 4, x minus 1. Then what do we have to do with those?
Divide by 2.
Okay. So that factors into x minus 2 to x minus 1. What about the denominator?
X plus 1, 2, x minus 2.
What happens?
X minus 2.
So when we didn't have any where this happened yesterday, but we've talked about it. When something cancels, what does that create on our graph? There is a hole on the graph. And you have to be able to give me the ordered pair. So the x value comes from the thing that canceled. What makes x plus or x minus 2 equal 0?
2.
The y value comes from if you plug 2 into the fraction that's left. So if I put a 2 in here, what do we get? Does everyone understand how I got that? The x came from the thing that canceled. We get the y by plugging 2 into this reduced fraction. To show that on our graph, it's just an open circle. So at positive 2, 3, 4, so we have an open circle on our graph. All right. X-intercepts. We said that's when the fraction is equal to 0, which is really the same thing as just when the numerator is equal to 0. And what does that give us? Over 1 divided by 2. So we hit the x-axis at 1/2. Y-intercept is where you cross the y-axis. So you plug in 0 for all of your x's. You can do the original or our reduced. I'll just go to the reduced one. So if I put in a 0 on top, I get -1. On the bottom, I get 2. So -1/2. And then we did our asymptotes. Vertical asymptotes. X equals, where do we look for that? The bottom. What makes the bottom 0?
-2.
So vertical at -2. Then we have to decide horizontal or oblique. How do we decide that? Divide our leading coefficients. You can do it in the original or the reduced. It won't matter. You're dividing those highest powers of x. What happens if you do 2x squared divided by x squared? 2. So if the x's cancel, that's horizontal. Y equals 2. So now we need the graph. We know what the right-hand side has to look like, I think, because we have a few points and we know it has to get closer to our asymptotes, so it's going to have to look like this. On the left side, it could be either above or below this horizontal asymptote, so let's pick a number. What could we plug in? You can do the original or this reduced one. I'll just go to my reduced. So I would get -7 over -1. So +7. So if I have -3, I get out 7. You don't necessarily have to plot it, you can, but all we really need to know is that's bigger than the horizontal asymptote of 2. So this section of the graph is up there. Is that one okay? Any questions? Let's try them. So first step, we factor. Top would factor into x plus 4, x minus 3. Bottom factors into x minus 3, x plus 2. What happens? That cancels. So we get x plus 4 over x plus 2. Okay, because it canceled, we know there is a hole in the graph. Look at the thing that canceled. What makes x minus 3 equal 0? To find our y, we plug 3 into what's left. So that gives me 7/5. So x-intercepts are when the top of the fraction is 0. It's when the whole thing is equal to 0, but just equates to the top. If you set the top equal to 0, we get, oh, that's if you put it, you're on the, just the top only, so that would be negative 4. Y-intercept is when we put in 0 for both of our x's. Because across the y-axis, x is 0. So we just get 2. Vertical is when the bottom of the fraction equals 0. So that gives us negative 2. And that is a line, so you have to have the x equals there. Horizontal or oblique. So if we divide x squared over x squared, what do we get?
1.
1. Horizontal y equals 1. Do I need test points? No, I can tell right now this is below my horizontal asymptote, so just make sure as you draw your curve is getting closer. How are we doing with these? Do we need another one, or do you feel like you've got it? Think we're good? Okay, I'm going to come back in a little bit and do handout is due tomorrow. We are at the end of a chapter. We're getting closer to a test. Tomorrow I will give you a study guide and the day to work on it. We will be going over that study guide as a class on Monday, and the test is next Tuesday. If anybody wants their study guide today, they are certainly welcome to it. but your degree is your highest power if you were to multiply all of this out. So if I multiply this out, in my first parenthesis I have an x cubed, in my next parenthesis I would have an x, in my last one I would have an x squared. So overall, what's my degree? My end behavior. We know if it's an even degree, it looks like a parabola. But what does the negative in front do? So both ends are going down. All right, the next one. Zeros and multiplicities. So it's already factored for us. If it was not, we would have to do P's and Q's to factor it. What would make x plus 1 equal 0? And since it's cubed, that would be a multiplicity of? What about x minus 2? What about x minus 4? Okay. Notice our degree was 6. How many zeros do we get down here? We have 3 different ones, but we got 1 3 times. We got a 2 and we got 2 4s. So we got 6 zeros. Our degree and our zeros match up. Okay, through or bounce. That's based off the multiplicity. Odd multiplicity will go through. This is a multiplicity of 1, so 1 is odd. That will go through. 4 multiplicity of 2. 2 is even, so that one will bounce. How do you find a y-intercept? Okay, if I put in a 0 for all of my x's. So I get 2, 32. And then we graph it. Okay, we found all this stuff to graph it. We know both ends have to be pointing down. Our zeros are where we hit the x-axis. So at -1, 2, and 4. Y-intercept of 32. I'm not going to count by ones. Then we draw the graph. Remember, it has to be a curve, so no zigzags. It's starting down here. At -1, our graph should go through. So it's just going to hit that and keep going. Have to hit our y-axis at 32. Come back and hit the x-axis at 2. What happens at 2? Through. Come back and hit 4, and at 4 we bounce. So it should look something like that.
How are you using it?